Well, what's up, guys? I'm here again, Mr. Mendoza, and I want to thank you all for watching and subscribing to my videos. Now, I'm here today because, and you saw me dancing because our lesson for this afternoon is about forces in motion. Hmm? But what is forces and what is motion? Motion and forces. Motion and forces. Well, if you're ready to learn, and let's get this started. Come on. Hey, what's up, guys? I am here today to discuss about motion. When we say motion, motion is a change of position with regards to the reference point. So, when one object changes from point A to point B, then that is motion. When there is motion, there is movement. Just like what I'm doing now. I'm using this treadmill, and this is an example of motion. Speed. When we say speed, speed is measured through dividing the distance over time. Again, distance divided by the time. Now, you can see the speed of this treadmill when I increase from 5 to 10. And this is an example of speed. Distance divided by time. Oops, sorry, I forgot to put my pants on. See you later. I'm back, Mr. Mendoza, and welcome to my mobile classroom channel. I'm encouraging each and every one of you to like and subscribe and hit the bell button after watching this video. I'm here to educate every student, not only in my school, but also both 7th and 8th grade students across America and also in other parts of the world. And I'm here today to discuss about forces and motion. Now, as we continue with the force and motion, just like I promised the other day, I'm gonna upload again new video about the new topic. These standards fall under 8th grade, but this would also be very helpful, especially to 5th and 6th grade, or to those who are also in the high school as well, taking physics. Now, as we continue with our lesson, we are talking about the force and motion. Now, when we say force, force is a push or pull. Meaning to say, when you exert force, there is movement. When you push something or somebody, there would be movement, especially if you are exerting more force as compared with that object. Okay? Now, what about the net force? When we are talking about the net force is a combination or the sum or the total of all forces. For example, I am pushing one object and another person is also pushing that object in the same direction. What are we supposed to do? To compute for the forces, we just need to add all of them, then that would be force, or that would be the net force. Now, on the contrary, if I'm going to give you another example. For example, I am pushing this object towards north and another person is pushing this object on the opposite direction towards south. What are we supposed to do? To get the net force, we have to subtract. Again, we have to subtract because the forces can be added or subtracted to get the net force. It is very dependent on the direction. If it goes to the same direction, you have to add. If it goes to the opposite direction, you have to subtract. We're gonna go over with this as we go further with our lesson. Alright, now we are trying to review forces in the same direction, you have to add. For example, like this arrow, both arrows, one and the second arrow is going this direction to this direction, so you have to add. On the contrary, this arrow is going to my direction and the other arrow is going towards that direction. To get the net force, we have to subtract. That's it. That is now the net force. Alright, as we continue with our lesson, I'm going to teach you about the balanced and unbalanced force. When we say unbalanced force, the net force is not equal to zero. This takes place because one object is exerting more force as compared with the other object. For example, I'm trying to push something. Now, this force or the amount of force that I'm going to exert, for example, is 50 newtons. And then the object would exert about 25 newtons. What do you think is going to happen? Exactly. The object will move because it is unbalanced. Why unbalanced? I'm exerting 50 newtons. That object is exerting 25 newtons. So I exerted more force as compared with that object. So that is as an example of balanced force. What are we supposed to do if I am pushing this object towards opposite direction? In order for us to get the net force, we have to subtract. So 50 minus 25 is 25 newtons. That is an example of our unbalanced force. As we continue, let us discuss the next one, which is the balanced force. Balanced force takes place when two objects are exerting same amount of force. For example, I am here, seated on the chair. I'm exerting, for example, 100 newtons towards down. And this chair where I'm using right now is also exerting 100 newtons towards or pushing me up. So this object and me are exerting same amount of force. That's why there is no movement. So I am remain seated. But this will change if and when I'm exerting more force as compared with this chair. What do you think is going to happen to me? Exactly, I'm going to fall because I am exerting more force than this chair. So we got two types, unbalanced and the balanced. Earlier, I have discussed about motion. Then I know most of you have already the background of what motion is. Motion is a change in position from one position to another with regards to the reference point. So any object, including me or anything or something or anybody that moves, then there is motion. Motion is simply defined as movement or change in position with regards to the reference point. All right, now speed. Speed is the rate of an object with regards to two factors. Number one is the distance, the second one is the time. In order for us to get the speed, we have to divide the distance over the time. Now, which of these two objects is faster in terms of speed? Letter A, the car is moving 50 miles north. The second car is moving 100 miles north. Exactly. Well, we cannot identify which of these cars is faster because I just gave you the miles or the distance, but the time is not present. What about on the second example? Which car is faster? The one that took about 10 minutes and the other one that took about 5 minutes. Exactly, none, because we cannot identify which one is faster. I just gave you the time. What about the distance? This car might travel for 10 minutes, but how far? We don't know. But the other car also traveled this amount of time, but we don't know. So in order for us to get the speed, we have to divide the distance over the time. Example, I drove down to the market yesterday and I consumed about 10 minutes and the distance is about 20 miles. So 20 divided by 10, then that is the answer to the speed. What's the answer? Exactly. So 20 divided by 10 is 2 miles per hour. So in order for us to get the formula of speed or to get the answer of speed, this is now the formula I'm giving you. So the average speed is equal to the d over t, or d stands for the distance and t stands for the time. We have to divide the distance over the time. For example, I drove down to the market yesterday about 15, or should I say 20 miles per hour. So that is too slow, like a snail, right? What about the other day before that? I drove down to Blackville with an average speed of 50 miles per hour. What about that? Is that faster? Fair enough? Good. All right, now let's continue with velocity. Velocity is the same as speed, but it tells or indicates direction. For example, this is an example of speed. 50 miles per hour, that is speed. But if it is velocity, 50 miles per hour north. So, velocity is the same as speed, but it tells or indicates direction. Acceleration. Acceleration is the change of speed per unit time. So, this is an example of acceleration. I was driving to my office with a speed of 55 miles per hour, and suddenly I realized to change my speed into 60 miles per hour. So that is an acceleration. Acceleration is the change in speed per unit time. Acceleration. So, as we continue with our lesson, we will be talking about Newton's law of motion. Newton's law of motion comprised with the three categories or the three subtopics. Number one, Newton's first law of motion is called inertia. Inertia is regarded, or this is referred to as, an object will remain at rest or continue on moving unless acted by a force. So, for example, this tablet or this keyboard will remain on my palm unless I will drop it or unless another force will pull it down. So, anything that remains at rest or not moving will remain at rest or will continue to move unless acted by a force. That is an example of Newton's first law of motion, inertia. Let's carry on with the second law. The second law of motion is F is equal to m times A. F stands for force, and m stands for mass, and A stands for acceleration. All we need to do is to multiply m by A. But what does this stands to, or what does it mean? Well, m, just like what I said, it is the mass, and A is the acceleration. As we continue with our lesson, Newton's second law of motion, we are talking about the F is equal to m times A, or the force is equal to mass times acceleration. For just to refresh your mind, m, or the mass, is inversely proportional with acceleration, which means any object that is heavy is accelerating less or would accelerate less because it needs more force, or we need more force to accelerate this object. So whenever you are trying to lift something that is heavy, you need to exert more force because the greater the mass, the lesser acceleration, or the opposite. The lesser the mass, the greater acceleration. That is now the second law of motion. Now, let us discuss the third law of motion, also known as the law of action and reaction. Now, if you are familiar with this, for every action, there is an equal and opposite reaction. This takes place or very evident if you have your rubber band and you're trying to stretch it, and then when you release it, it will bounce back and sometimes hit you. But if you really exert it up to the exert or after the to the extent that it was to its limit, and then when you release it, it will hurt you more because the greater the force that you exerted, then this object will will also exert opposite force. That is now the action and reaction, are also known as the Newton's third law of motion. For every action, there is an equal and opposite reaction. Now, let us now recap of our lesson for this morning. Again, we discussed about the forces and motion. Force is anything that causes motion because force is referred to as the push and pull. Now, if there is force, there is motion. Now, we discussed about the definition of it. And then what about the net force? Net force is the sum or the total of acting forces. It could be divided, it could be subtracted if two objects are moving in different direction, or it could be added if these forces are acting or moving towards same direction. It could be added just like in number one, or it could be subtracted just like in example number two. Now, balance and unbalanced force. The first one is unbalanced force. This takes place whenever two objects are exerting force that are different. So the net force is not zero. While the balanced force, two objects are exerting same amount of force. That's why it is called a balance, because there is no movement at all. We discussed about motion. Motion is movement. Speed is the change of, or speed is equal to the distance over time. So you have to divide the distance by the time covered. We also discussed the formula, and then velocity is the same as speed, but it tells direction. Acceleration is the increase in speed per unit of time. Newton's first law of motion is inertia. Anything will remain at rest unless acted by a force. The second one is F is equal to m times a, where F is force, m is mass, and a is acceleration. In order for an object to accelerate more, you have to exert more force. And mass, or m, is inversely proportional with a. Now, the Newton's third law of motion is stated as for every reaction, there is an opposite and equal reaction. I hope you like and you learned a lot to my lesson today, to the mobile classroom. And I hope we could be together in our room as a normal class, and we are together with this. Let's continue to pray. Thank you. All right. So stop.